Hello, welcome to this sixth and last session of this mathematics workshop. In last session we have transformed all 2D and 3D objects. Now, we will be creating a 3D object in with Excel, and for that we will be using some advanced technique, unique technique we should say, to convert any 3D object in 2D. So, first requirement is that if you think that any 3D object, when we see, where we see it? We see it in a plane, that any photo picture all we have seen plane. So, indirectly we can say that any 3D object can be make in the plane. So, that is the rationale of doing these things. Here we will create a cube, and cube size I have given this data here, all x, all y, all z, and as per 3D object as homogeneous coordinates requirement, we will put all h is equal to 1. So, this will be our coordinates, and with that, for transforming those in x, y, z direction, we will be adding some y rotation, we will add some x rotation, and we will add some z projection. What will happen then? We will move this in y direction first. Y direction means this is the y axis if we think. So, we can move it like that, and then we will move it like that x direction through x axis, and all this result we will project in a z is equal to 0 plane, means x y plane. So, this will be our orthogonal object of a cube, and this data I have shown here. You can show this data I have generated here, and these are the things, cos f 2, sin f 2, like that we have created this y rotation matrix, and we have put a slider here which will help in rotating in x direction, y direction, and this is our cube we have formed, and we know that how we can form. You can see this is I am rotating through x direction, and this it will be rotating in this is our cube. Earlier you can see it was a only square. Now, it in 3D isometric projection we can see it as a cube. So, this is a unique thing we can do in a 3D object, any 3D object like that we can project in a 2D plane, and this is the isometric projection. So, going back to our discussion, where we have started that linear and non-linear. So, we will start now non-linear objects. Characteristics of non-linear lines, curved lines. We will come back to our original discussion. We started with that math can be made easy if we can see it through lines. So, we have explored straight lines. Now, we have tool to control the line or any point in a space. Now, we are going back to what happens to see in curved lines or non-linear equations or non-linear functions. So, if you characteristics of non-linear systems. To demonstrate this non-linear system, we will first create a non-linear function like that, y is equal to, suppose just take any function like that. and draw this curve in Excel. This is your assignment.
Homework or now?
No, the assignment means it has to be done now. No. And I will guide you how to do that. You take any values of, no, I should not guide.
First we take the value of 0 and then we start.
Okay. I will give something. He has elaborated nicely, and actually we should proceed like that. X you take, so minus 3 and go on incrementing minus 3 plus 0.1, a small increment. So, you will get a smooth line, and you do that and copy this cell. Suppose it is C2, copy this C2 and drag it up to bottom.
Interestingly, 0 नहीं आता है इसमें. It says 1.53 e raised to minus 15. 0 आना चाहिए.
Minus this is scientific way it is taking. If you give it as a number, this is format is general, it is written, no? There if you put it is a number with decimal numbers, it will give a number. Otherwise, this is scientific format of X. So, this is our data, and now if I want to plot this, this will be our curve. So, this is our curve. Okay. Now, if I go back to our discussion, you see this any function, nonlinear function will have independent variable x . Not coming? What is the issue?
स्टार्ट से जाइए.
स्टार्ट से जाइए ना.
-3 से
-3 से लेके +3.2 ऐसा.
-3 तक तो आपका जा भी नहीं रहा.
डेटा सीरीज एडिट कीजिए जरा एक बार, सेलेक्ट डेटा में जाइए,
You help
एडिट
Anand? You help?
assuming that it is from
Okay. So, what is the slope of this line?
slope of this line.
Yes.
It's a variable.
Huh?
Vary, na?
Yeah.
3x square plus
So,
4x.
variable, what does it mean?
That as one moves along the curve, the slope keeps on changing. Slope of the
Very
tangent
good.
keeps on changing.
So, straight line we have seen that slope is always constant, but first thing is that in non-linear function, first thing slope will go on changing. So, what will be the slope here? How we can find out the slope of this line, you know?
Differentiate it at a particular point.
Okay. If you have not learned differentiation, I have not learned differentiation, how can I find the slope?
You will take two really close points on the curve, just draw a line between
And
them.
draw a line and
y2 minus
make it to
y1 upon
approximate.
x2 minus x1.
So, y2 minus y1 divided by
X2
x2 minus x1, that I will do. So, I have not learned, I am physics class 9 and I am suppose I have not visited any college. So, we do not know that calculus. So, what we know? We know that difference of y1 and y2 and difference of x1 and x2, then it will give the.
That means you are approximating the adjoining 2 points. by a
I
straight
do not
line.
know whether
Because you are treating that as a line, right?
Yeah.
That would be the slope of the chord, and if that interval x2 minus x1 is very small,
Limit as then all
then
those
it will
limit kind of
become-
things will come
yeah,
start
Yeah.
coming in.
then it will approach to.
So,
this
so
line
we
will be the
will
limit.
we'll do that here.
Wow.
Here we will do that x2 minus x1, we know that now for formula is x2 is this one x minus x1. You also try this and copy this formula throughout. y2 minus y1 so this is it till dx. Okay. First point you are having liberty to choose any point. Hmm?
Anything before that.
No, first point you skip, then it will be good.
Now what do we say? What do we put?
So, I have calculated dy dx and no, not yet. For x, if I take x, we have having liberty to take any value others. So, I have taken 5 minus 5. So, corresponding to what will be y, I told y is equal to x cube plus 2 x square plus 5. So, x cube, this is x, minus 5, this is x cube, this sign is cube, and then 2 into minus 5 whole square, again you can put bracket and whole square, plus 5, that 5, that formula I have put, and once this formula it will calculate automatically and it will give a number, and then in this corner point if you click, all the point corresponding to minus 5 plus 0.1, if you go on adding all these points. So, every 0.1 interval it will draw the line. So, draw line is there and you should get a curve like this. This curve, red curve. Raise hand. Okay. Any issue?
Yeah, we done that before.
Raise hand. Okay. So, what this red curve signifying? What this red curve is signifying? Changing slope. How I will be knowing that? Oh, means actual physical interpretation.
Variation of slope with x.
So, suppose I asked you the minus 4. What is the slope at minus 4? Achha, it is visible there. You have calculated, no? You have not taken this formula? No, okay. You have there in there. So, from there you tell what is the slope at minus 4?
I can tell you what is the slope at minus 2.9.
Minus 2, what is that? Minus 2?
Minus 2.
Minus
4.41.
Very good. Minus 4 to 4. What is it is telling actually?
There is a line whose is increasing line with a slope of 4.41.
Very good. That means what I have plotted, this is actually derivative of this function, but at minus 2, suppose this is minus 2, you are telling it is how much? 4.41. What does